I will travel where no man has dared to go.
The accepted laws of physics break down.
Boundary between the known universe and a place beyond the reach of science.
Alright everyone, welcome to the video. So the first thing you should do obviously is start out by drawing yourself a force diagram. Okay, so start off with the block that's being pushed and then look towards the message. It says its mass, and in this case it says 75 kilograms. So right away think about gravity's acting on the 75 kilograms, and of course there is an oppositional force pushing back up. That's the force normal. Okay, so the thing to think of right away is that force pushing down. Make sure you understand the difference between mass and weight. The force of gravity acting on the mass creates the weight. Okay, once again, weight is what happens when gravity acts upon the mass. The next thing is you want to go ahead then and multiply it by the negative 9.8 for gravity. So you take the 75 times the negative 9.8, or your mass times gravity, and you should get a negative value that is pointing down. And since the object is not moving, we know that it has a net force of 0. So therefore, in the opposite direction, there has to be 735 newtons pushing back on it, and that's happening from the floor. Alright, so just like before, in 2D kinematics, we needed to use time as our bridge between the x and the y axes. Here our bridge is going to be the coefficient of friction. Okay, and remember, the coefficient of friction will be some sort of decimal point. Well, what that really means is that instead of experiencing all the weight like I would if I was pushing up on the y-axis, because of friction, I'm only going to experience a percentage of the weight. So you take your coefficient of friction and you multiply it by your weight, and what you get is the force of friction. It's the force that opposes your movement, or your force to have the object move. So now that I have that information, I can look and I can see that my net force says that I have 15 newtons of net force. Okay, and that means that 183.75 newtons is opposing it. So I realize I'm more into the positive. Okay, so that means my force net is greater. So how much greater? 15 more. So in this case, I write down my force net equaling 15. I look at my frictional force, and I just realize that whatever my applied force is, it has to have been 15 greater, because I came out positive 15. Okay, so just think of what number is 15 greater than 183.75. Okay, so in that case, in your mind, you just should be able to add them together and realize that it's 198.75. Okay, so then you take that and you write that down, and that will show you exactly how much force applied you gave earlier. Alright, so now that you've solved everything for the first part and drawn your free body diagram, the next thing you do is go to the next question, and it says, what does the static coefficient tell you? And use the percentage. Once again, it tells me that when I push on it, I will experience a resistive force that is based on 25% of the object's weight. Okay? Because the coefficient was 0.25. So once again, what it tells you is that what percentage of the weight you will experience on the x as a resistive force. If I was on the y and I went ahead and tried to pick it up, I would experience 100% of it. But in this case, it's telling me the percentage I'm going to experience that opposes my movement, because it's a frictional force. So it's very important. It's not the mass. Once again, it's not times the mass. It's the weight. There's a difference between the two. Alright, now to the next question. This one, if you only applied 10 newtons of force, what would your frictional force be? This one is one of the difficult questions. This is why I'm very hesitant just to give you guys equations to use. Because you have to understand what's happening in the physics of it. You cannot just go ahead and punch numbers in. Okay, the math is there to support the concept. The math does not drive the concept. Because in this case, if I only put 10 newtons of force on the object, I learned earlier that the frictional force required to push the object was 183.75. So if I only put 10 newtons on there, I am not going to have enough, okay, to move the object. So therefore, I can't just take the 10 and combine it with the max frictional force required, because I'll get a negative value. I have to use logic then. And that logic tells me that even though I apply 10, it's not moving, so my force net is still 0. So think about it, there's really no way in the world that anyone can really measure something's frictional force, even with the blocks that we used when we did the lab experiments. What you measured was the force you applied. And you saw that it would move after a certain threshold or it wouldn't move at all. You can't move frictional force, so then you have to realize that for every single time you pulled on the force gauge to move the block or the spring scale and it didn't move, that the frictional force value must have been the same to keep giving you a net force of 0. Because the math has to support the action in the concept. It doesn't drive the action in the concept. So this next question just deals with what we talked about earlier with the only applying 10 newtons. What would your net force need to be? Well, anytime something doesn't move, or if it is moving and there's no change in the velocity, that means that there's no force present, so the net force would have to be 0. Okay, net force of 0 means that it's just staying the same way. And why would this be true? Because a 0 net force means there's no force and you need a force to change movement or direction. Alright, this is just if the material has a kinetic friction of 0.18. So now that the object is moving, you simply go and look at what all your information was from the beginning. What your force applied was from the first, what the weight was, the negative 735 newtons, the opposing force of that to give you a net of 0 on the y. And then now I'm going to do a new frictional force. So I just take this one and multiply it by the weight. So take 0.18 or find out what is 18% of the weight of the negative 735. And in this case, I come up with 132.3. My force applied stayed the same, so the 198.75 is what's applied. Okay? So that gives me a force net, when I compare the two on the same axes, it gives me a force net of 66.45 newtons. And now from here, I go back to the same equation again when it says below it, what will be the acceleration with the kinetic friction. So I take my mass of the object because I'm looking to find the acceleration. So F is equal to ma, so in this case it is going to be F divided by the A equals m. So I have my force net of 66.45. I take that and I divide it by the 75. Kilograms, and what I will get is an acceleration of 0.886 meters per second squared. Alright, for this final question, this is a question to think about troubleshooting and seeing how all of them relate with each other. If you think about it, if you have no force, okay, there's an object right now that you're looking at, your computer, your laptop. It has no force acting upon it, right? It's not moving. So then where does the 0 come from? Why is there no movement on it? And this is applying all of our old equations. So if you think about all the equations that we've ever used, we'd be able to look at it and see that, okay, force is made up of mass times acceleration. Well, your computer right now is not moving and it has a mass. So that means the zero has to come from acceleration. And then what does acceleration mean? Well, it's a change in velocity over a change in time. Well, time is still ticking right now. So it has to be there's no change in velocity with your laptop. And look at it. Still at a consistent velocity of nothing. So then I look into velocity. And I see that velocity is equal to displacement or change in distance over time. And in this case, your computer is not moving anywhere. So from a math standpoint, if you look at the zero starts with distance. And then it gives you, if you have zero distance, you have zero velocity. If you have zero velocity, you have zero acceleration. And if you have zero acceleration, you have zero force. So from here we can write no force is equal to no acceleration. If I have no acceleration, it's because I have no velocity or change in velocity. If I have no change in velocity, it's because I have no change in distance or displacement. So that is how all of these tie together as we continue to build upon these in physics. So that's it. That's the concept to help you overall in the coefficient of friction. And if you actually took the time to watch this whole entire video, on the bottom of your quiz, please write the word pineapples. Please don't tell anybody else. Thank you, and have a good weekend.
At the brink of the node, science is a collaborative enterprise spanning the generations. We remember those who prepared the way, seeing through them also.
If you're scientifically literate, the world looks very different to you, and that understanding empowers you